So on 33, you're playing a children's game in which the number of spaces you get to move is determined by the rolling of a die. You must land on the final space, exactly on the final space in order to win. If you are 10 spaces away, how many turns might it take you to win? Okay, so you rigged up an experiment and did it?
Yeah, but what happens if you go past 10? Like, does it make you go back, or do you just stop?
That's a good question.
I didn't really know what happens with the game.
So it is the final space. Notice it says that. So there is no going past it. So if you roll something beyond it, you just stay put.
Oh, I didn't know that. I thought you. So that's why mine was all messed up.
So it's like until you get a 10?
No.
So until you get one that gets you to 10.
You gotta get exactly 10.
So if you get like a 5, you get like a 7. Wait, that's not possible. You get like a 6. Then you just stay at the 5.
You just stay at the 5.
And then you move up to the 7, and then you get like another 5 or something.
So what I did was, if you got more than 10, I just stopped it. Which was
I really don't. I don't know.
So I only had 1 out of my 6 that got exactly 10.
I kept doing it until I got 10.
Yeah. So I was like,
Yeah, and so what's going to happen is there's a lot of times you're going to get really close and then have to roll a lot to get in. Does that answer your question?
Yeah, I just didn't know what happened if you got more than 10.
Yeah.
Now I do.
Yeah, it probably could have been a little clearer on explaining that part of it. But certainly you aren't going to go past it.
Yeah.
Kelly?
Can you do number 37?
37.
This one was.
Four couples at a dinner party decide to play a board game after the meal. They decide to play as teams of 2 and to select the teams randomly. All 8 people write their names on slips of paper. The slips are thoroughly mixed, then drawn 2 at a time. How likely is it that every person will be teamed with someone other than the person he or she came to the party with? Okay, so... Hope that's not what I wanted to do.
Have a banana, Mr. Davis. I was just remembering when we were online, we wouldn't answer.
So wait a minute. Where did you hear about have a banana?
Like, we would be online and we'd be in there, and we wouldn't like respond to your questions because nobody would get off mute. And you'd be like, "Have a banana, Mr. Davis." Nobody's answering me.
That is something that my family uses to check to see if people are paying attention or not.
Well, maybe pay attention on that.
All right. So, did you have any kind of an inkling of how to set up your experiment?
What? What I did just doesn't make sense. You know what I mean? Like, I don't think it had any logic to it. I would do like the little.
All right, gentlemen.
Like I'd pair them. I'd do the like 1 to 8 thing with like 2 at a time, and so then I would put like 1 and 2 were partners, 3 and 4, 5 and 6, 7 and 8.
Okay.
And so then I would do like a little random little calculator thing, and if they were like 2 different people, I'd like mark that, and if they were different people, I'd mark that, but I didn't know where to stop or where was enough, and I didn't really know if it was even correct.
Okay. So it's difficult to know exactly how to do this because you're like, well, how do I keep track of these people, right? So to make it simple, let's say that their first names begin with A, B, C, D, E, F, G, H, right? So helps if you put it back on pencil. First names start with A through H. And then A and B are married. C and D are married, etc. That makes sense? My writing's almost as bad as Lily when I go fast.
I
Wonder
wish
if-
that you can watch the video.
I watched
Okay.
the video. What was his name? It was the Rose one.
So the hard part about this is that when you're drawing the names, you're going to have some sort of way of randomizing what you're drawing, right? And the problem is also that there are fewer names every time, right? And if you draw your own name, then you put it back in and you draw again. There's a lot going on in this, okay? So what I would do is A draws first.
So the people are drawing?
Yes. Oh, then draw two at a time. Sorry. I didn't read carefully.
So many moving parts. You gotta make sure you get this.
So you draw two. Okay?
An outside party.
Yeah. The referee. So for the first draw, we need two random numbers from 1 to 8 with no repeats.
Yeah.
And then for the second draw, we would need two random numbers for the rest. For the the easier way to do this is your calculator has a random number no repeat built into it. Let's look at that rather than write all this stuff out.
Just do 8 of them. Okay.
Um,
Right. Couldn't you just draw 8 and the 2?
yeah, and the first two are the first pair, the next two are the second pair. So let's get rid of all that. So if we go to math, probability, it's number 8, random integer, no repeat. So I want from 1 to 8. And if we do it this way, all we have to record then is, do we have any couples that are together? So here, that's a couple, right? Because that's B and A. 6-4, that's not. 5-3, that's not. So what is the last one? 8-7. So actually, we have two couples that are together on that one. But all we need to do is record whether it's a couple or not. And then we can just do this over and over and over again. That makes sense? Yes.
It's just so much.
Have you found out how to scroll on the numbers yet?
Oh, that's a really good question.
Just out of curiosity. Then I can do this faster.
If you go up and hit enter, I think you can scroll. Because then it moves it.
If
have
you
to
go up,
so it selects it, the answers, hit enter,
Mine doesn't do
or maybe
that.
not. Yeah. Because sometimes when you do that, it puts it into like the expression line, like when you were typing
And then
stuff,
you can, like,
and then you can
down.
scroll through it. That's what it does on mine. But
Unfortunately, I'm not so much.
mine uses C a lot.
Yeah, it's retro screen.
No?
oh, it did it now.
How did you do that, sir?
I just did it again, and now it let me do it.
Stupid calculator.
Oh.
And just beat it like that.
Okay. So enter.
You're so smart.
Yeah, because when you do it again, then it puts it into the line that you normally type stuff in, so then you can kind of
So I have to like hover
move,
below.
I think.
So how many trials would you do for this? Like,
45.
okay.
I think in the book they said do at least 20 trials for any of these.
That,
I did 10.
I mean, that's how you do it. Well, obviously it is. But, like, it's just so much for, like, one question, you know?
Yes.
Oh yeah. Doing things this way is very difficult. Part of what they're doing here, honestly, is we're going to get into probability later, and they're going to be like, yeah, remember when you had to do, all the trials and you weren't at all sure if that was, even correct? Well, now we're going to teach you how to do probability on some of these things, and you can figure out what the theoretical probability is rather than the simulated probability.
Which one tends to be more? Simulated obviously tends to be more accurate, right?
The theoretical is more accurate. Yeah. The theoretical is what the simulated should settle down to if you do enough
But
trials.
how do you figure out theoretical without doing simulating in the first place? I guess you're going to teach you that. All right, sounds good.
Yes.
Very nice.
Can we do it in StatCrunch, the simulation?
Yes, you can use StatCrunch for the simulation. Some of them work really well. Some of them not so much. And I haven't figured out everything on StatCrunch how to do the simulations and make it work real well.
Don't lose your marbles.
I have one more question. It's not
Yes.
about a specific number, but
You go
Yeah.
to apps.
All
on the
right.
ones where you're, like, writing out the whole chart or whatever, and on the answer key, it'll say, like, answers may vary, but the average is around, like, 15% or something like
Right.
that. What if you get 45%, but you did it correctly?
That's certainly possible.
So you can get, like, any percentage as long as you did it, like, right? That's, like,
Yes. Although if I got 45 and they said the average should be around 15, I would be worried that I did it wrong.
What's, like, the cutoff for, like...
There is no,
cutoff?
which is why on a test, I'm not going to ask you to perform this kind of a simulation. I can ask you, how can you set up the simulation? Right? You should be able to answer that. But I'm not going to ask you to actually perform the simulation because all kinds of crazy stuff can happen.
Okay. That makes me feel better.
Yeah, and some simulations have greater variability than others.
Spin.
I have no clue.
Set.
All right, now I'm curious. So Andrew, if you turn your your calculator off and then back on, the first time you do it, math, probability, 8. We wanted numbers from 1 to 8. Oh, it works now. Weird.
I guess we fixed some setting by doing what Ian said.
I have no idea.
I won't complain.
I won't either. Any other questions?
Yes, sir.
All right, then let me get today's notes on chapter 11.
It's there. Beautiful colors. Mine. Not going to cast mine out to you guys again.
Yet.
Thank you.
Certainly.
No, thank you.
Thank you.
You're welcome.
I think my name's in blue or pink.
Purple.
Aquamarine.
Aquamarine.
They did a really
Great.
Superb.
I don't think I've ever been this awake at school in my entire life.
We'll take that as a compliment.
Actually,
All right.
I was awake. I did my
So
code last year.
let's see if they watched the video. There's a quiz on Chapter 10 on Tuesday.
Oh, no. Do we have a quiz tomorrow?
Honest. That's for real. We have a quiz on Chapter 10 on
They said we had it
Tuesday.
on Monday, and then been like, they had listened to the video.
Yeah, that'd be fun.
They'd be ready.
All right. So here's the deal. If we're looking to try and make some sort of a conclusion about the world at large from data, there are three different ideas. The first one is, well, you can't examine everybody.
Aw.
Okay, it's just not going to happen. And even if you could figure out a way to do it, the amount of time that it would take, lots of things would change before you were finished with all the examinations, even if it was something simple. So we'd like to know about an entire population of individuals. But examining all of them is usually impractical, if not impossible. So we settle for examining a smaller group of individuals, a sample, selected from the population. Okay, that makes sense. In fact, your book, actually some of the auxiliary stuff talks about this. In most cases, it's not just that we don't know exactly something about the population. Frequently, it is unknowable by human beings. There's just no way to find out. So, sampling methods that, by their nature, tend to over or under emphasize some characteristic of the population are said to be, anyone want to guess what this word could be?
Bad.
Correct first letter.
Bias.
Yes,
Oh.
biased.
Bad.
And bias is the worst thing ever. Okay? If you have bias in your sample, you can just throw out anything that you get from it. It's not going to be worth it. Sometimes you can fix some other things that have gone wrong with your data, but if you have a sample that's biased in some way, just throw it away, start over.
Fun.
Okay? So, number 2, randomize. So, randomizing protects us from the influence of all the features of the population by making sure that, on average, the sample looks like the population. If we truly pick a random slice. Okay? What's important about this? Well, the fraction of the population you sampled doesn't matter. That one rubs counterintuitive for a lot of people. The proportion doesn't really matter unless the population is small and the sample is more than 10% of the whole population. It's the sample size that's important. Whether you are trying to get something, a piece of information about all the people that live in Texas, which would be a quite large population, as opposed to the population of the United States, right? You don't need to, I don't know, what do you think Texas's accounts for? Let's make it easy. Let's say it's 10% of the overall population of the US. Okay? You don't need to, if you're doing it correctly, you don't need a sample that's 10 times bigger when you're trying to find out information about the US.
Austin face.
There are times that I love being here and times not so much.
Yeah.
Invite him in. Be like,
Nah, you
Maybe he'll invite
you
himself.
get a headache.
Okay?
Nah, nah.
So, how large the sample needs to be depends on what we're estimating. And we'll get to that later. But it's not the proportion or the percentage, it's how many you sample. You need a certain number in order to make things work well, even if that population is enormous.
So there's like a set number that you need to hit.
Depending on, and it depends on what it is you're trying to figure out. We'll get to that, but not today. But it does, I understand, it totally kind of runs contrary to the way you feel it ought to be. It's like, for a bigger population, shouldn't I have a bigger sample? Not necessarily. Okay? Now, what's a special population that includes everyone?
Population.
census.
A census.
Hey. Sensei.
A census is a special population that includes everyone. So the question becomes, well, why not do a census?
That's
What-
hard.
Well,
It takes time, money, energy.
yeah, it can be difficult and expensive.
Nice. That's
Both
fair.
are bad.
Yes. That and populations are changing all the time, so that a census that takes a long time to complete may give us outdated information. By the time you finish the census, it's outdated. And then for large populations, a census is really complicated. Your book talks about this very briefly because they're trying to stay away from the politics of it. But doing a census of the US population like we're supposed to do every 10 years is probably a waste of money.
There's one thing the United States likes, wasting money.
Yeah. There are better ways to do it statistically that would be way cheaper.
Like what?
But it has become, well, take the correct size sample.
Google.
Google. All right. So,
Check your Gmail.
something I want you to remember, that population goes with parameters and samples go with statistics. So you do statistics on a sample of the population. You can find parameters if you know something about the entire population, which is almost never. So if you're looking at the mean of the entire population, we use mu.
That's the friction coefficient.
Yes, same thing. For the statistics, we do y bar, right? Yes.
So when we use parameters on like a normal model, does that mean that the normal model is a population?
Yes, if you're doing it on the whole population, yes.
Okay, because when we were working with normal models, we were using parameter signs, right? I think.
Yes, because we were doing it on an entire population.
Okay.
Yeah. And it can, honestly, I still am a little iffy on some of it. So for standard deviation, if it's a statistic, we use S. If it's the entire population, for a parameter, we use sigma. Okay? Correlation is R. I've never seen correlation used for the entire population. But if you do, it's row.
Huh.
Okay? The regression coefficient is B. Again, I've never seen it done for the entire population, but you would use beta. And then, of course, it breaks down here for a proportion. We use p hat. And for the parameter, we just use p.
Ooh.
Why they don't use, and I understand, why don't you use pi? Well, it's been co-opted by the math people.
I think.
Pi has been taken away.
Isn't there another option?
No.
Well, you would want something that starts with p.
Well, move doesn't
That's a
start with
Greek
Y.
letter.
Good point.
Pardon?
Move doesn't start with Y.
That's for mean.
I
There
see.
really aren't any others.
Well, there are other ones, but I don't think there are any other ones that start with P. Let's see, alpha, beta, gamma, delta, epsilon,
Silence and epsilon.
U, nu, psi, omicron, pi, rho, sigma, tau.
So on.
Yeah, I used to know all of them. I don't know them all anymore. And it ends with omega.
Yes.
I just remember it starts with alpha and beta because that's where we get the word alphabet from.
Makes sense.
I guess I never really cared enough to know that.
Yeah. All right. So a representative sample makes the statistics that we compute reflect the corresponding parameter accurately. Sorry, you having trouble reading my really bad handwriting there?
No.
It wasn't you.
I think it's actually great. It's much better than mine. So.
Now, generally speaking, the one that everything else gets compared to is something that's called a simple random survey. This one is used so often that, and it's such a long word that they call it SRS for a simple random survey. And the part about this is it's designed so that every individual has the same chance of being chosen, and every combination of people has an equal chance of being selected as well. Has to be both of those things to be a simple random survey. So for example, if I was sampling students at Northland, right, and I randomly picked a pre-cal class, and then I randomly picked people out of that. Before I picked the pre-cal class, everybody had an equal chance of being picked, correct?
Yeah.
But as soon as I picked the pre-cal class, can I get every combination of people that I might possibly want?
Nope.
No. So that's not a simple random survey.
So in order to make it a simple random survey, you just don't pick the pre-cal class.
Pick every class.
Yeah, it has to be one big group, and you have 250, and it's like, all right, I want 10 of those. Calculator, give me 10 random numbers between 1 and 250, no repeats. Okay? Then the sample space is a list of individuals from which the sample is drawn and must be carefully defined in order to match the definition of the population. Samples drawn at random generally differ from one another, right? If I randomly selected 10 people out of 250, then I selected another 10 out of 250, they're not going to be the same. these sample-to-sample differences in whatever I'm measuring are called sampling variability. So if you were measuring height, and let's say I was using as my population students at Northland, and I randomly selected 10 students out of that, found the mean height, and then I did that again for another set. Is it likely that the mean is going to be exactly the same? No. That's sampling variability. Okay? All right. A simple random survey is the standard against which other sampling methods are gauged. This is generally considered to be, depending on what you're doing, one of the best. There are reasons to do other ones, though. Let's look at some other ones. So sometimes the population is sliced into homogeneous groups. Do you know what homogeneous means?
Same.
Yeah, they're the same in some parameter. These are called strata. Before the sample is selected. Then simple random sampling is used on each stratum before the results are combined. Strata, plural, stratum, singular. This is called stratified random sampling.
But not SRS.
No.
Oh, that's so annoying.
Yes, it is. So
They couldn't have just thrown like an extra word in there and just like.
instead of calling it stratified, call it something else? Yeah.
Strata-ratified.
Something that doesn't start with S.
SRRS.
Stratified.
So
Really random sampling of SRRS.
this might be something that you want to do if you think that those two groups have differing opinions about something, or they may be different in some way. For example, with my height one, I may want to put, men and women in two different strata, and then do my sample on each of those and look at each of those individually, because there are two different groups that are likely to have different things going on. Okay? Now, splitting the population into representative clusters, then selecting a few clusters at random and perform, that's not a census. Oh yeah, a census on each of the clusters is called, not surprisingly, cluster sampling. And frankly, this is usually done to make it cheaper or more convenient. In some cases, it works out really nicely, but not always. Okay? Sampling schemes that combine several methods are called multi-stage. Samples. Most surveys that are done by professional surveyors are multi-stage. They may break it into strata, and then within the strata, they may take clusters. So they may be doing multiple things. We don't deal a whole lot with multi-stage sampling because it just gets too complicated for us. Okay? So when the order of a list is not associated with the responses sought, we could randomly pick where to start and then pick every nth person on the list. So we make a list of the people. The order that they are on our piece of paper isn't important, and we pick every seventh person. Okay? This is called systematic sampling. Because you have a system for it, okay? And your book does a really good job. Be sure, when you read this, read it carefully. It talks about how to sample badly. In other words, things to avoid when you're sampling. One of them is to sample volunteers. That's called a voluntary response sample and leads to voluntary response bias. Okay? This is why internet polls, I'm like, who cares? Or local TV shows. Of the people who responded to this, I'm like, that's not worth the time and energy it took to calculate anything. Okay? Convenience sampling. Convenience sampling is usually, I'll ask my neighbors. That's an example of convenience sampling. It's lazy sampling. Okay? Using a bad sampling frame, one that doesn't include all of the population in question. Undercoverage. So if I am, for example, let me think of something that would be undercoverage of some portion of the population. Oh, so if I sampled people at the football game tonight about how they feel about the amount of money that's spent on fine arts productions, I'm probably undersampling some group there. Okay? Non-response bias, this is where you send out a questionnaire and for whatever reason, some group chooses not to respond to it. Okay?
Kids don't respond to it.
So it's called non-response bias. They're like, they don't give you any answer at all. And you can also have response bias, which is not the same as non-response bias. A lot of times that's the wording of the question. Anything that influences the responses. And you'll see this, you'll see examples of it in the text, but you'll ask things like, do you feel that the United States should spend more money on the military to keep us safe from foreign invaders? You're like, what? What kind of a question is that? Yeah. All right. Any questions? Again, it's really important that you read the book. It gives you way more illustrations than we have time for in class.